Okay, we've got one more wrinkle to show you on this idea of solving trig equations by hand, and it's what to do if you've got an input that's not just x. So like in this example, we want to know what solutions on the interval from 0 to 2 pi we would get for sine of x over 2 equals 0. Well, the basic of this is essentially the same idea, but I need to do a little bit of prep work mentally ahead of time. I'm going to find values where x over 2, where the sign of that equals 0. So I'm going to get some set. I don't know exactly what the numbers would be. And actually, well, let's just pretend there's that many of them. But if I were to do that, if I were to only look between 0 and 2 pi, when I multiplied this by 2, I would get too many values. So I need to think through this idea for a second. I need to make sure that when I get x, just x, I get values that are from 0 to 2 pi. If you've never seen it before, this little symbol here means x is in the set. X is an element of. Okay, so when I write this, I mean x is in the interval from 0 to 2 pi. But the thing of it is that if I divide that by 2, then x divided by 2 should be in the set 0 divided by 2 is 0. 2 pi divided by 2 is just pi. So here's the thing. When I look for my values, I'm not going to look on the whole unit circle. I'm only going to look right here from 0 to pi, because I know that when I multiply both sides by 2, I'm then going to have values that will be between 0 and 2 pi. So it was worth it for me to sketch this out briefly now, so that I only pick out the values that I need. So if I go to my unit circle, I want values only from 0 to pi where I get a sine of 0. So on my unit circle, sine is the y-coordinate. And if I'm only looking from 0 to pi, where's the only place that I get sine to be 0? Well, it's actually right here. It's at 0. From 0 to pi, not including pi. And notice that when I set my thing up, yes, sine of pi is 0. Sine of pi is 0. But when I set up my interval, I said I'm not including pi in my answer. So the only value for x over 2 that works here is 0. Now the other thing that is worth pointing out is that I don't want to solve for x over 2, I want to solve for x. So I need to multiply both sides by 2. And this is kind of a basic and maybe simple example, but the only value I get is x equals 0. That's the only value between 0 and 2 pi where x divided by 2 gives me 0. You might say, well, what about pi? But pi, sine of x is 0. But sine of pi, if I divide it by 2, I don't get a value of 0 now. I get sine of pi over 2 is 1. Okay. Let's do maybe a slightly more informative example. We want to solve all the values. We want all the values between 0 and 2 pi, where tangent of 2x is negative 1. So I'm going to do that legwork again. The first thing I'm going to do is I'm going to look at what I've got to work with. So when I get x, I need x to be on the interval from 0 to 2 pi, not including 2 pi. But I've started off with a 2x expression. So the thing to do to get from x to 2x is to multiply by 2. So I better multiply each of these values by 2 also. I better start looking not from 0 to 2 pi, but from 0, which is 0 times 2, to 2 pi times 2, that's 4 pi. So what I need to figure out is where on the unit circle, where is the tangent negative 1. And I need to look on 2 trips around the unit circle. I need to look from 0 to 4 pi. So here's my unit circle. I want to know where the tangent is -1. And I see a value here that works at 3 pi over 4. Here at 5 pi over 4, the tangent's 1. But 7 pi over 4 works also. Okay? But now here's the thing. Maybe I'll list them out here. 3 pi over 4 and 7 pi over 4 work. But I need to look from 0 to 4 pi. So on my second trip around the unit circle, if I landed right here, I would also get a tangent of -1. What angle would that be if I went all the way around one time and then stopped here? It'd be the same as this plus 2 pi. 3 pi over 4 plus 8 pi over 4, it's 11 pi over 4. And then if I were to look here, adding 2 pi, 7 pi over 4 plus 8 pi over 4, that's 15 pi over 4. So all 4 of these values are ones that I'm looking for. So 2x would be 3 pi over 4, or it could be 7 pi over 4, or it could be, we had 11 pi over 4, or 15 pi over 4. But the thing is, I'm not done. I don't want to solve for 2x, I want to solve for x. So I'll divide both sides of this equation by 2, and it's weird to use that notation to talk about dividing a whole set, but I think that's okay. I think you know what I mean. Let's write our answers. Let's say x is, and I'm going to divide each of these values by 2. If I divided 3 pi over 4 by 2, I would get 3 pi over 8. If I divided 7 pi over 4 by 2, I would get 7 pi over 8. And similarly for the last two, we're at 11 pi over 8 and 15 pi over 8. These might be good opportunities again to check your answers, okay? And I'll model that really quickly. So if I were to take one of these values and plug them in for x, just to check my answer, is the tangent of 2 times 3 pi over 8, is that equal to -1? Well, 2 times 3 pi over 8 is 3 pi over 4. And if I check my unit circle again for the value of tangent of 3 pi over 4, I'll see that, yeah, that's -1. So yeah, we've got that one right, and the others work out as well. Thanks for watching the videos today. Good luck with this, and remember, you've got a lot of assistance if you need it.